In this video, we are going to show and discuss the double displacement reaction that occurs between sodium hydroxide and nickel chloride.
To begin, take two 50 milliliter beakers off the shelf and place them onto the lab table. Next, place 15 milliliters of our 1 molar sodium hydroxide into one of these beakers. We will then rename this beaker Beaker 1 NaOH, the chemical formula for sodium hydroxide. Note that this solution is clear and has no distinct color. Now, we're going to add 6 milliliters of our 1 molar nickel chloride into the other beaker and rename it to Beaker 2 NiCl2, the chemical formula for nickel chloride. Interestingly, this solution has a green color. Listed here are the colors of several aqueous transition metal ions. Our solution is green in color, and this is consistent with the color of nickel shown here. Now, transfer all of the contents of one beaker into the other beaker. At this point, a small green precipitate has formed in the beaker. This prediction is consistent with this because nickel hydroxide, one of the products that was formed, is insoluble in water.
Okay. Here we have the reactants, which are sodium hydroxide, which is a strong base and completely dissociates in water, as we can see in the table here. For sodium hydroxide, its soluble is a lot. Then we have nickel chloride, which completely dissociates in water also. And now here we can see the chemical equation already balanced for the reaction. We have 2 moles of aqueous sodium hydroxide that react with 1 mole of aqueous nickel chloride to produce 2 moles of aqueous sodium chloride, and lastly 1 mole of nickel hydroxide, which is the precipitate, as we can see in our reaction. Products. First we have sodium chloride, which is a salt and completely dissociates in water, and lastly we have our green precipitate, which is nickel hydroxide and is insoluble in water. Here, as we can see, is the precipitate, which is green in color, and in our case, when we mix the reactants, the nickel hydroxide precipitate, and due to its greater density, went to the bottom of the beaker. This is what we call a double displacement reaction.